Number 3. Okay, what did you?
I thought, so I know that y prime is dy over dx, but I didn't know how to do that.
So rewrite it as
Then you distribute it.
dy over dx equals x. Y distribute what? Nope. I'm going to multiply both sides by dx.
Okay.
So x squared plus 1 dy equals, yeah, x, y, dx. Okay? So that means the y's rule the left side and the x's rule the right side. So I have to divide by, and they're going to go to war, yeah. So I have to divide both sides by y, and I have to divide both sides by x squared plus 1. So over here those cancel, and I get dy over y, and over here these cancel, and I get x over x squared plus 1 dx. Okay? Now what? Yep, antiderivative of both sides. So antiderivative of y over y is natural log of y. This one, unfortunately, is a little bit tricky because you have to make a u substitution. So we have to use our old techniques of integration to solve some of these. So that means the derivative of that is 2x dx. So I got a 1/2 du equals x dx. So this becomes 1/2 du over u. So now I can do the antiderivative because I know the antiderivative of du over u is what? Natural log of me. So that's going to be the natural log of y equals 1/2 natural log of, but it's u, but I'm going to substitute it back in there because we're done with that. X squared plus 1 plus c.
And the other times I supposed to c as well, but we just...
Wow, I even am like a native English speaker, and that was so fast I couldn't even get anything in there.
So the other times follow plus c, but we just...
Right. Really, you just have to put a plus c on the x side. Yeah. Okay. Okay, we're not done though. Okay, so we got to solve this for y. Not yet. And this is where Mackenzie and I ran into trouble yesterday. You can't e both sides because that 1/2 is in the way. So I'm going to make that be a power. And now I'm going to e both sides. So when I e this side, I get y. And when I e this side, I get e to the natural log of x squared plus 1 to the 1/2 plus c. Not yet.
Is the plus c in the exponent?
Yeah, because it's this whole thing becomes the exponent. So now I'm going to rewrite that as y equals e to the natural log of x squared plus 1 to the 1/2 times e to the c. Right, so this is just c. And then now you can do what you said, and the e and the natural log will cancel. You can't do it when it's plus thing in there technically. So it's y equals c times, those cancel, x squared plus 1 to the 1/2. Good stuff, huh? My 1/2s look like y sub 2. I don't know what to do about that. It's been happening a lot lately. Need to maybe make the 1 like straighter upper and can't touch the fraction line. Okay, give me something to work on this summer. I can come into my classroom this summer and work on my 1/2s. I usually write actually better with my right hand because I have to go more slowly because I have to think a little bit, yeah. This is all sloppy because I'm just going fast. Yeah, because you, no? Oh, okay. Okay, now what? 4? What'd you say, Mackenzie? Punch who in the face? Why? Because he's, oh. Okay, so, yeah. And the joke, Brooke gets the joke in 10, 9, 8. What?
Somebody asked for I thought you were talking about you. That's why I didn't get it. I was like, why isn't it always on the violence?
Violence is never the answer. Okay. So y prime is dy dx. Okay. So we're going to start by multiplying by dx, right? And then may I, in one step, without confusing anyone, also divide by y squared? Okay.
Honestly, no, but you do that.
Okay.
We'll be 3 seconds later. Wait, what?
Don't get mad.
So then I'm going to take the antiderivative of both sides. So that's y to the negative 2 dy equals sine of x. That's so awesome.
I can't go there without it, no matter what. No, if someone else would have done that, like no one ever talks to me, like, oh,
Apparently, everyone just sort of has. Okay, so antiderivative of y to the negative 2. Negative y to the negative 1. Yeah, we'll write it like that in a second. Equals antiderivative of sine of x is no, negative cosine. Yeah, antiderivative, right. Yeah. Okay, so this is really negative 1 over y. My mom has the same thing, but her thing that she brings out on everybody is everybody always asks her for directions. Like we have been in a foreign country before, and people will come up and ask her directions, like in German. You know, she's like, yeah. No, but she just looks really kind and motherly. So I think that when people are like confused or need help, they just see her and they go, "Oh, well, let's ask that nice woman there. She'll help us." This is kind of that. Okay, so how do you want to solve this for y? How do you want to solve this for y? You did the old switcheroo? Awesome. So we can make this 1 over cosine x plus c equals y. And then is that it? Is that it? Did you check the answer?
No.
I feel like, oh, that they're going to change it into like secant plus c or something?
I mean, you can, but do I want to?
I don't know if you can though, that's why I'm curious. Yeah. Okay, so we'll just leave it like that. Good enough for government work? Okay, questions on 4? We're just going now? You guys?
My problem is I started all of these, but then I get to a point where I'm stuck.
Uh-huh.
And so yeah, that kind of makes it unfortunate because you kind of have to go through boom. It's already like, oh,
Shoot.
Super what? Super speed? What is the antiderivative of tangent? Oh, we learned that. It's some natural log of like sine.
That was us.
Oh, okay. No, I think we got that together as a class.
What? What is it?
I think it's on, no, I think we did it as a class. The antiderivative of tangent.
maybe your license you remember to turn the lights off.
No, I think it was me and you talking about it.
It
It's
was?
like the natural log of, it's the natural log of secant.
Yeah.
It was not a multiple choice then.
But we didn't do that together as a class? Yeah, we did. Did it? Yeah. No, not we did it like we accomplished it or whatever. But in section 7.4, we figured out the antiderivative of tangent is the natural log of secant of x. Okay? We came up with negative natural log of cosine of x. But they take that negative in front and make it an exponent, so they make it cosine to the -1, which is secant. So either one of, yeah, do you remember? Because we did this problem and used a U substitution and then came up with this as our answer. Anyway, so the point is, we know that this is going to be natural log of secant of x. Oh, sorry, secant of y. Okay, what's the antiderivative of x squared plus 1? 1/3 x cubed plus x plus c. And I believe this is one that you cannot solve anywhere past this. Because this, and because the one of the y's is inside of a trig function and the other one is just by itself. No can do. Okay? Okay, so this one has r's. But
everyone's mean to me. That's why we can't be friends. I'm done. Okay, sorry.
This one has r's and u's, but it doesn't matter. Okay, it's just the same as x's and y's. So I'm going to cross multiply here. And while I'm at it, I'm going to change that to the 1/2. What? Thanks. Okay, so 1 plus u to the 1/2 times du equals 1 plus r to the 1/2 times dr. And then antiderivative of both sides. Antiderivative of 1 is u, because there's a du right here. Yeah, it's u. Plus antiderivative of u to the 1/2 is 2/3 u to the 3/2. Antiderivative of 1, now we have a dr. What? So that's going to be r. Plus, same dealio here, 2/3 r to the 3/2. And then who are we solving for here? Right, because this would normally be dy dx, and we would solve for y, so it's the top variable. So this is where the c ends up.
That's it, right?
Yeah, I don't like the idea of trying to solve that for u. Let me look and see if they find a way to do it. But so we can't simplify that. Okay? So you leave it there. How many did I make you guys do? 18. Nice. Good job. Okay, number 7 and 8. We can't do because we didn't learn integration by parts.
Oh, well, I tried to do 7. I think I did it wrong.
Okay.
'Cause I have
Number 9 looks a little bit intimidating, but let's give it a try. Wait. Maybe we can't do that. Can we solve that? No, let's give it a try. Let's see what happens. I should probably teach you guys integration by parts.
Who even do that?
I don't know. So do what now?
I have absolutely no idea.
Not even just the starting
The
one?
T's and the U's on?
Yeah. So I'm going to multiply by dt.
Oh, and then get rid of some of those U's?
I
Can we?
You divide by u.
I literally have no idea.
Yeah, I'm not so sure either because but then we've got dt.
1 year.
Which one is this? Number 9? What? That is not even fair.
How do you even
Which
do that?
one is the?
Oh, do you do it like where you take out a 2 and then a T?
Yeah, you
That
break
is-
them into.
Yeah, so if we take out a 2 from here, that gives you, yeah, that's exactly right. Good job. That gives you a 1 plus u, and if you take out a t from there, that also gives you a 1 plus u. So that means this factors into 2 plus t times 1 plus u. No. No. Yeah.
Now do we divide by 1 plus
Yeah, now we can use that to get the 1 plus u's, or the u's on the other side. Huh. Color me pink. Districts is Monday. We have no practice today. Huh? Oh, because we were tired from playing 18 holes yesterday, and we're gonna miss Monday and Tuesday, so we gotta, get our schoolwork, and I have to make sub-plans.
He's trying to see if it's
In other words, no, it's not. I'm not going to the golf course. In other words, you reach a stage where there's really nothing that Joa could do today that would make her more successful on Monday. You're just, you know what I'm saying?
Yeah.
No, as in golf, it's different than basketball or football, or it's not like we can work on our conditioning or put in a new offense or whatever.
But it's
She's as good as she's going to be.
not necessarily.
What?
I
'Cause
mean, there's nothing that she can. What you're saying is that there's nothing she can fix in a day.
yeah, it's golf.
She can get better at what she's doing. You know what I'm saying? So like,
Yeah.
basically like,
It's a risky proposition because I'm telling you right now, I know this as a golfer, we could go have practice at the driving range and she could hit the ball worse than she did yesterday, and then it would actually like screw her up. You know what I mean? Right. So
Yeah.
you reach a point where you're just like, okay.
But I feel like golf's kind of like the same way as basketball. So like, especially for high school basketball, some kids really have just awful looking shots, but they shoot so much that it works.
Then it
for 'em.
works, right?
That's the only time it's gonna be good is to be in high school, right?
Yeah.
I feel like it's kind of the same way for golf. Someone can get really good at bad things they
Bad
do,
form, right?
but it's still, I mean, it works for me, but
Yeah, I know what you're
feel like
saying.
they're continually working on the things they do.
Yeah. Well, it's going to be okay. We'll be all right. Okay, so are you with me so far? No, we're not even close to done yet. So we did this little factor trick, which came out of nowhere. And then the antiderivative of this is just the natural log of that, right? Okay. And then the antiderivative, antiderivative of this, I can go term by term, right? Now I am going to e both sides like we have done before. So the e and the natural log, of course, cancel. So I get 1 plus u equals. And then this I'm going to write as 3 separate things being multiplied together. So I'm going to make it e to the 2t times e to the 1/2. There's that bad 1/2 again. 1/2 t squared times e to the c. Right, so this becomes just a c, subtract the 1, so u equals e to the 2t times, I don't know if they would like us to combine those things. Can I just parallelogram it and be,
You don't need a C in there anymore.
It looks like a bread.
Oh, I thought it was that. Oh, the princess here.
I did that before, but it looks like a 1, so I put 100 instead.
okay, let's make sure we know how to do number 10.
No, I put 100. I put 190. Should have been 90.
Okay, there's no integration by parts.
Yeah, not that. No.
Okay, so what do we got going now? No? Subtract. So dz over dt equals negative e to the t plus z. That's like a little rap. dz over dt equals negative e to the t plus z. What? Neither. We are going to,
Break it up.
yeah, kind of. So we're going to make it negative e to the t times e to the z. Now you multiply by dt and divide by e to the z. It is. So I'm going to freak you out and do this in one step. When I divide by e to the z, since the exponent is on the bottom, I can make that e to the negative z, right? Okay. Equals negative e to the t dt. Okay? Antiderivative both sides. Actually, no, it just happens naturally. That's why. Yeah, exactly. It's just in me. What they say about artists is that artists always have like a song that they need to get out, or a story to tell, and that's just how I am, Mackenzie. I just always. Antiderivative of e to the negative z.
You should just take over Miss Patton.
Negative e to the negative z.
You could have a songwriting class.
Antiderivative of e to the t. E to the t, and we have that negative in front, so we're going to go negative e to the t plus me. Now we're solving for z. So can I do this? Can I make this a positive and this a positive and leave that as a positive? Are you okay with that? But yes, I can. Okay, now I'm going to natural log both sides. So the natural log of e to the negative z, the natural log and the e's cancel. Equals the natural log of e to the t plus c. I don't know if we can in this case because it's a natural log, not the e. So I think that's all we can do. I mean, we have to get rid of the negative. Why what? Yeah, right. So I can't use that little trick. Let's see if the... Hang on just a sec. Yeah, they just have... Yeah, they just have that. They made it e to the t minus z, c, but you know, whatever. It's all good. Moving on. Is this something different now? Oh, okay, good. Now we get to actually plug in some numbers, and so Caleb doesn't have to be so frustrated with the C situation. True. So this is y dy equals x dx. So antiderivative both sides. So that's 1/2 y squared equals 1/2 x squared plus c. Huh? Y the c? Not yet. I got to solve for y first.
So we're going to multiply by 2.
Multiply by 2. So y squared equals, just love this so much, x squared plus c, because 2 times c is c. Okay. And then y equals, I guess, plus or minus the square root of x squared plus c, right? I don't know. Why is it just what? Because this is addition and square root is the opposite of multiplication, so you can't do that.
So it was x squared times 2.
Yeah. Yeah. Okay, so now we can plug in for our initial conditions. So if I plug in 0 here for x, then that's going to equal -3. So -3 equals plus or minus the square root of, just c, because that one is 0. So c equals 9. Do, 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 do. Yeah. Yeah? Yeah. Do you want to try this one on your own? Can you do any of these by yourself?
Nope, that goes higher than that.
So just take a couple minutes maybe, get started, and see how far you can get. Okay? Yeah, I think. Nope.
Oh, because of y, divide by y.
No, I would go divide term by term. So make this y to the -1 and make that y. So what she was asking is, do I need to do use substitution? And I said, no, I'm going to write this as two separate things, as 1 over y plus y. Doo-doo. Sorry, Elizabeth. She probably doesn't appreciate the singing. Okay. Now I'm going to do both sides. Oh, no, that's what it is.
Oh, yeah. I got you. That makes sense.
This one can't be solved, so we just plug in what we've got right now.
It's the y that's it's x.
Not for y, no. So you plug in 0 for x, so sine of 0 is 0. So c equals the natural log of 1 plus 1/2 times 1 squared. The natural log of 1 is saying e to the what power equals 1, 0. So that means we're just left with c equals 1/2. Colby, what kind of shape do we want to use for this one? Go triangle? Ooh, radical thinking. Okay.
I am terrible at drawing stars without.
Okay, can't do 13.
Can't do it.
Can't do 13.
Should we try it?
We can do 14. Try what?
Try making a star without like the line going through the middle.
Oh.
Like an outline of it.
Uh-huh.
Try it.
Okay, will you guys start on 14? So just like this, you mean?
Yes.
Okay.
Not bad. Yeah, weird.
That's pretty good.
This is a little, yeah, I missed that one a little bit.
Oh, I'm so bad.
Shadow.
What?
Yeah, it has a shadow.
Yeah.
That's kind of fun.
It is weird, yeah.
Shadow looks good too.
The shadow looks good, yeah, it's true. So you can't see all those. Okay, you guys are doing calculus, right?
Yeah. Now make one the lines go there better.
Can't do, we don't know how to do number 13. You know what that makes me think of? Mm-mm.
Oh.
No.
Patrick Star.
Christmas cookies. Sugar cookies with frosting and sprinkles on them. Oh, so good. Help.
I'm already excited for Christmas.
Goodbye, little cookie. Okay, so what do you got so far, Brooke? Okay, so dp equals, can I just anticipate and make this p to the 1/2 times t to the 1/2? Because I feel like that's going to be, not yet.
So then divide by p to
Right, and so again, since I'm dividing by p to the 1/2, and then that makes the thing on the bottom, I'm going to make it, p to the negative 1/2 dp equals t to the 1/2. Then I take the antiderivative. So the antiderivative of this is 2. Oh, 2. Oh, yeah, because it's not till 2p to the 1/2, which you said equal. That's what I was thinking. 2/3 t to the 3/2 plus c. Yeah, you can. So you can divide by 2, which is the same as multiplying by 1/2. So I'm going to say p to the 1/2 equals 1/3 t to the 3/2 plus c. And then that's p to the 1/2, so to solve that for p, I would square both sides. And I don't particularly feel like foiling that whole thing out. All right, Colby said do it anyway. So 1/9 t to the 3/2 times 3/2, you add the exponents, so that is 6/2, which is 3, plus these two things multiplied together and then doubled, so that would be 2/3 c t to the 3/2, and then plus c squared, but c squared is just c. I don't really like that we did that. I don't, that's, no, c squared is just c.
That's like saying 1 equals 2. Yeah. Like right there. Is that true?
That's the answer.
Yeah. But they just left it like this. Sorry, Colby. Oh, yeah, thanks. Not true. You will be sitting in a classroom next this November. You'll do it on your own. Yeah, maybe not. Maybe January. I don't know. No, you're fine.
I feel like I'm probably not going to get to that.
September. Okay, we'd like to start the class with differential equations. Do you remember? I'm out. Peace. Want to be an art major? Follow my bliss.
It would be easier to
Really old because that is one of the first albums I ever bought. Sgt. Pepper's and Earth, Wind and Fire. I was probably like in junior high, so maybe 1980 when I bought that album. I don't really know if that was their first album. That's an interesting question. It'd be fun to know that. Huh? Yeah. What? Oh, good Lord, no. It's probably scratched all the poop. I was in junior high, you know. I didn't. Okay. Yeah, this one looks like the variables are nicely separated for us already. What is the name of that album?
The first one?
Yeah,
I don't know.
I don't either. I know.
Unreal?
What was the other one? Oh yeah, Boogie Woogie Wonderland. Boogie Wonderland. Yeah. Okay, so integrate both sides.
So when did we get a hyperbolic practice again?
So the antiderivative of 2u is u squared.
What the heck one am I on?
No, the other side has a t squared, right? And then the antiderivative of secant squared is tangent. So this is not that hard. Earth, Wind and Fire. Does it have the playlist? I'm trying to think if that is actually the...
Help somebody, moment of truth, love is life, and a fire. Come on, children, this world today, bad human.
I don't think that was the one. What's the one that has September on it? The song is called September. Do you remember 21st night, September? Body, say to you. Elizabeth is just, oh, she hopefully turned the volume down a long time ago. Okay, so you plug in 0. So C is 25? Okay.
Alright, I dare you to sing that song
Around Riley? Who's Riley? Why? Do it. Just do it. No, I feel like I'm kind of bored of this. Yeah, are we done with this? Tiana, have you had enough? Yeah, okay. What's that? Yeah, that's what Jake said too. Okay, so that's that.